What do you do when you have a lemon and nowhere to go? When life gives you lemons, fight back with some calculus. Are polar equations killing you like global warming is killing the polar bears? Up until now, we've been using Cartesian, or rectangular coordinates. Polar coordinates may seem like a totally different language, but don't worry, we can solve this lemon by doing some good old calculus. Polar coordinates are just another way to define space. Instead of moving horizontally and vertically to define a point, we can go straight out from the origin until we hit that point. Then we determine the angle that this makes with the x-axis.
Then what do? Well...
When life gives you lemons, do calculus. Lemons are good.
So let's try the first problem. All we have to do is use the Cartesian to polar conversion formulas. They are r squared equals x squared plus y squared, r equals the square root of x squared plus y squared, or theta equals the inverse tangent of y over x. So let's try it. So let's say our rectangular point is -1, -1. Since we need to find r, we plug in x and y into the first conversion formula. So r squared equals -1 squared plus -1 squared. Then we see that r squared equals 2, so r equals the square root of 2. Peasy lemon squeezy. Then to find theta, plug in the coordinates into the third formula. So we get theta equals the inverse tangent of -1 over -1. So theta equals the inverse tangent of 1, which equals pi over 4. If you notice, the point -1, -1 is in the third quadrant, but the point √2 pi over 4 is in the first. So in order to fix this, we just have to add pi over 2 twice, or pi, to get to the third quadrant. So the real coordinate is actually √2 5 pi over 4.
Molly's face in HD. Annie's face in HD. Yeah. It's recording? Oh my god! It's the little imperfections that make us beautiful, Molly. You don't have to wear makeup, girl. You don't have to do your hair, girl.
Yellow marker.